This is section 8, implicit differentiation, example 1, parts C, D, E, and F. So we're going to keep going. We're going to jump right into part C. Now in part C, we have x squared times y, so those are two different equations again that are multiplied together, and x times y squared. So we're actually going to be using the product rule twice. Okay, separately, but twice. So let's go ahead. We have the first equation. So x squared times the derivative of the second, which is dy dx, plus the second equation, y, times the derivative of the first equation, which is 2x dy dx. I'm sorry, not dy dx, that's an x. So dx dx. Okay, that was the first two terms, right? So that's right here. Now, plus, and then we have to do the product rule again with xy squared. So we have the first times the derivative of the second, which is 2y dy dx, plus the second, which was y squared, times the derivative of x, which is dx dx. And all of that is equal to the derivative of 2x, which is 2 dx dx. Okay, now before I do anything, just remember that this is how I'm setting it up. However, because it's all addition, there's nothing to distribute in. I use the brackets for your sake. Now I'm going to take them off. Okay, because I don't actually need them, and it might end up getting more confusing if they're there. So, because there's nothing to distribute, I don't have to worry about them. Now the first thing I'm going to do is cancel all of my dx dx's, because that's, again, something else that's just going to get in our way. So let's get rid of all the dx dx's. Those are 1. And 1 times something is just the something that's there. And our job is to get dy dx to one side. So I'm going to move everything that does not have a dy dx to the other side, which includes this. Let's see, that has a dy dx, and this. So my x squared dy dx stays over here. And my x, actually I'm going to write that as 2xy because it's prettier that way. Dy dx is going to stay over here. And that's going to equal 2. Now when I move things over, they're just going to end up being subtracted. So we end up with 2xy and minus y squared. Now again, just like on the last problems, the dy dx's are both on the left side. They're in both terms, so I'm just going to take it and factor it out. So my dy dx ends up on the outside, and on the inside we have x squared plus 2xy. And that's going to equal 2 minus 2xy minus y squared. If I want to get dy dx by itself, I'm going to divide by everything that's inside the parentheses, which means dy dx ends up equaling the 2 minus 2xy minus y squared divided by the x squared plus 2xy. Now my job is to take 1, 1 and plug it in. So if I plug in 1, 1, then we get, let's see, we get 2 minus 1, those cancel, and 1 plus 2, which is negative 1/3. That's the answer. Another one, tangent. Now this one doesn't give us a point, which means we're not plugging in a point, we just want to solve for dy dx. So, because I have a function inside of another function, I have to use chain rule. I take the derivative of the outside first. Remember, the derivative of tangent is secant squared. The inside stays the same. And then I multiply by the derivative of the inside, which is dx dx plus dy dx. And that equals the derivative of x, which is dx dx. Now this is why, when we cancel these, those become 1s. Okay, because we really have secant squared of x plus y times 1 plus dy dx equal to 1. Now, there's a couple ways I can do this. My job is to get dy dx by itself. That's right here. Okay, so I could start by dividing the secant squared, right? Just divide it out. So let's do that. So I'm going to divide both sides by secant squared of x plus y. That'll cancel that. Okay, but now I still have 1 plus dy dx. So to get rid of the 1, I would subtract it. So minus 1 to both sides. So dy dx ends up equaling 1 over secant squared x plus y minus 1. Okay, 2 more. We have y plus the square root of x times y. X times y is going to be a product rule, and there's something outside of it. So we get to use the chain rule. So before I do that, I'm going to rewrite it as x times y to the 1/2 power, and that'll help me out a lot. All right, so the derivative of y is dy dx. For the chain rule, we're going to take the 1/2, move it to the front. The x times y stays the same because it was on the inside, and then we multiply by the first times the derivative of the second, plus the second times the derivative of the first, and that equals 0 because the derivative of 0 is still 0. Again, we're trying to get, oh, and this is negative 1/2. Okay, so we are trying to get dy dx by itself. Dx dx is just 1. All right, let's see. What's the fastest way to do this? We're going to multiply it out. Yes, we're going to distribute. So dy dx stays the same. And I'm going to take this whole thing and distribute it to both of these. So we end up with, I'm also going to simplify at the same time. So you see how this x does not have a denominator. It's not in a denominator. It also doesn't have a negative exponent. So this becomes x over 2 square root of xy dy dx plus y over 2 root xy equals 0. Okay, now we need dy dx is on the left side, so I'm going to move this one to the right. So if you don't mind, I'm just going to put equals and stick a negative there because that's what would have happened if I wrote it all out. Dy dx is in both of the terms on the left-hand side, so I can pull it out. So we have dy dx times 1 plus x over 2 root xy equal to negative y over 2 root xy, which means that if I divide dy dx, ends up equaling, now this is going to be very, very ugly, negative y over 2 root xy divided by 1 plus x over 2 root xy. Okay, now we have to plug in 2, 2. So evaluated at 2, 2. So we end up with, negative 2 over 2 root 2 times 2. Well, 2 times 2 is 4. Root 4 is 2. 2 times 2 is 4. Divided by 1 plus 2 over 4. Okay. That means we have negative 2/4 times 1 plus 2/4 is 6/4, but we take the reciprocal, so it's 4/6. Those cancel. That becomes a 1 and a 3. The answer is -1/3. Okay, one more. Sine of xy. This is a chain rule where xy is the inside. So the derivative of sine is cosine. Xy stays the same. But we have to multiply by the derivative of xy. That is a product rule. So we have the first times the derivative of the second plus the second times the derivative of the first. And that equals 1 dx dx. Now, dx dx goes away. That's a 1. That's a 1. We're just going to do what we did with the tangent. We're going to divide first because there's only one dy dx that we need to isolate. So that means that if I divide, we have x dy dx plus y equal to 1 over cosine of xy. Now, I will, well, 1 over cosine is just secant. So I can change that, make it a little bit prettier, secant xy. That helps because now when I subtract y and divide by x, it won't be so ugly. So I'm going to subtract y. So we have x dy dx equal to secant xy minus y, and then divide by x. So this stuff goes away. And that's the answer.